Okay, I already recorded this once, but I was not able to post it on the video on the device that I recorded the video on because the Wi-Fi adapter is fucked. Okay, so here goes. Minimum value to get positive step-by-step sum. Given an array of integers nums, you start with an initial positive value start value. In each iteration, you calculate the step-by-step sum of start value plus elements in nums all the way from left to the right, and you're going to return minimum positive value of start value such that the step-by-step sum is never less than 1. To accomplish this, we're going to use a prefix array. We're going to use a prefix sum array. So we're pretty much just going to be, so for example, right, if I had nums here, if we did a prefix sum array, that would be negative 3, that would be negative 1, negative 4, 0, 2. So since we want to make sure that the step-by-step sum is never less than 1, we always want it to be 1 or greater than 1. And so if you notice there, 1 is pretty much the smallest value can be. So we might as well find, and we want the minimum positive value. So we want to find a value when the smallest number in nums prefix sum array is equal to 1. When it's equal to exactly 1, then we found the minimum positive value. So in this prefix sum array, the smallest value was a negative 4. So for example, if you look at this example they gave us with this array here, it becomes negative 4 at some point. So 5 would be the start value, right? So then we get 1 because 5 plus negative 4 is 1. All right, well, let's build this. Pre-sum is equal to nums of whatever is at 0. For I in range so from 1 to the length of like nums. Okay, so we should probably also have the min, because we're trying to the min start value. So the minimum start value should be just really high. So 100 is the highest the number can be, and then the length highest is 100. So that's 10,000. If you multiply that, theoretically, the bound's 10,000. So you can just go 1, 2, 3, and 1. All right, or something like that. Should work. For I in range, this pretty much just gonna go pre-sum dot append pre-sum of I minus 1 plus nums I. Yeah, and that should work. And if pre-sum of whatever is at I is less than the min start value, then min start value is equal to that. Yeah, and then so basically they also told us that the minimum positive value of start value, minimum positive, so it has to at least be 1. So if so here, let me explain the math right away real quick. So for example, right, our smallest value, so min val, whatever we get, the smallest value in the prefix sum array plus x, we want that to be 1. Okay, plus some number, we want it to be some number plus that minimum value should be equal to 1. We want to find the number x, which will added to that min value will get us 1, because for this part, ignore this stuff. Right here, step-by-step sum is never less than 1. So never less than 1 means it can be exactly 1 at its lowest point, and we still meet the constraint. And we want the minimum positive value, so we want the one that will keep us at 1 or above at all times. So, minimum value plus x equal 1. So if you rearrange that, by the way, that way we're going to calculate x just 1 minus min value. Okay. So if 1 minus min start value is greater than or equals to 1, return exactly that. Otherwise, return 1. That should work. No, it doesn't work. Can only concatenate list, not integer to list. Okay. So I messed up somewhere. Pre-sum dot append pre-sum of I minus 1 plus nums of I what? The prefix sum is I, therefore it would be 1 to begin, and 1 minus 1 is 0. We'd be getting pre-sum of 0. Oh, is there an extra 1 thing here? Dude. Oh, fuck. Okay. It's on me. No, it's late. It's like nearly 2:30 a.m. And I just pulled an all-nighter to study for a final last night, so I'm pretty tired. Input's -12. Okay. So we got 1 because it never checked that. For some reason, the minimum start value, could just be nums. Oh, I forget, we need to check that. That would be the minimum start value, not that weird integer. We'd start at nums of 0. Yeah, that would be correct. Otherwise, we'd never check that first element. Valid syntax. Dude, I need to sleep. I need to go to sleep. Okay. Space complexity is O of n, because we iterate through the entire list of nums. I guess minus the first element, but it's still pretty much n. And then or did I say space? I meant time complexity. But I guess space complexity is also O of n though, because we're building a prefix sum array based off the input nums. Yeah, that's about it. All right.